Initially here, we're going to be watching oxygen released underwater and kind of see what it does. This lab is going to involve the rapid release of oxygen out of a solid compound. This 25-minute video is going to take you from the pre-lab through the lab and the actual post-lab with all of the information. So you're actually getting 3 days worth of material out of this 25-minute video. So please do realize that. Hello folks, today we are going to be going over the 75s lab. You're going to need a periodic table, your 75s worksheet, a calculator, a sheet of paper to take some notes on as we're going along, as well as your back cover. This lab is going to be very similar to the hydrate lab. In the hydrate lab, we drove off water out of a compound and we were able to get the grams of water in that compound. This lab is going to be very similar to that. We're going to have a compound that's got oxygen gas locked up inside of it, and we're going to figure out how many grams of oxygen are actually driven off from this compound called potassium chlorate. So take some notes as we're going along. And we haven't quite decided the value of this lab. We're thinking somewhere between 3 and 6 homework grades. So the first thing I need you to do is to balance this equation. So pause the video, balance this equation on a sheet of paper so you have it for yourself. This is a skill you should, in fact, own. So pause the video and try to solve this. So assuming that you spent some time solving this, potassium chlorate is K, that's potassium. This is the chlorate part, KClO3. Yields is the arrow. Oxygen gas is O2. And potassium chloride is KCl. We would then do the elements. So we got potassium, we got chlorine, and we have oxygen. And now we'd have to figure out how many we have of each. We got 1 potassium on that side and 1 potassium on that side. And we have 1 chlorine on that side. We have 1 chlorine on that side. This side we have 3 oxygens, and this side we have 2 oxygens. So at this point in time, with the chlorines and the potassiums all balanced out, I would say, how do I make this side into 3 oxygens? If I have a 1 here, and there's a 1 in all these blanks at this moment, if I have a 1 on this side, I only get my 2 oxygens. If I put a 2 on this side, well, then I have 4 oxygens. That's too much. So what's between 1 and 2? That would be 1.5. That's 1 oxygen and another O. So that's what 1.5 gets me. So now I have to multiply the whole thing by 2 to get my proper numbers. So I cross that out, and I get 2 KClO3. I no longer have 1.5. I have 3 oxygens, and I have 2 of the KCl's. So hopefully you're able to do that on your own. You're going to hand write this report. It's not going to be typed out, so you're going to hand write this report. I'd suggest using a pencil. Some of the things that you're going to need in your report, it's going to be a title. And if you look at your 75s, it goes through exactly what you need to do for the title. It involves your name, some of the information from the lab. So just look at the 75s. Everything is there for you. That's going to be due tomorrow. That should take you all of about 1 minute to write out. The problem, again, look at the 75s. The problem is right there for you. That should take you about another minute or 2. Procedure, you're going to write up as much of a procedure as you need to perform the lab. So as we're going through some of the procedural things today, write some of those things down. So right now, you're just kind of taking notes, and you're going to make it look a little bit better after you put it all together. You're going to have a data analysis section, and in that section, you're going to have a data table, which we'll talk about in a little bit. And you're going to do a factor label problem again, which we will talk about in a little bit. So the goal of the lab that you're going to be performing, which is the 75s, is to figure out how many grams of oxygen are theoretically released from 2.00 grams of potassium chlorate. And you can use a factor label problem to solve that. And you've done many of these problems. This isn't even as complicated as what the worksheets are. So you're going to start with your 2 grams potassium chlorate, and you're going to do a factor label problem to find out how many grams of oxygen came out of it. So you're going to do that in a little bit. Then we're going to actually do the experiment with 2 grams of potassium chlorate, and we're going to find out how many grams actually were released from that sample. Then you're going to compare those two, the theoretical. Theoretical is the math. The actual is the lab. And we're going to calculate a percent error between those two. So this is kind of what the setup is for the lab. So this is things called an evaporation basin. You can call it a basin. You can call it a dish. We really don't care too much. You don't even need to write all these things down, but this is the basic setup that we'll have a ring stand. We'll have some energy, a flame coming out of the burner. It will be heating up our sample and driving off our oxygen. So this is a little bit more representative of what we're actually going to do. We're going to have a flame down here. It's going to be heating up our evaporation basin. We'll put our 2 grams of KClO3 in there. We'll turn on the flame. This will start to bubble. That's the oxygen actually escaping. Our solid will turn into a liquid. And then eventually, as enough oxygen actually is released from it, we'll be left with KCl in the container, and that'll turn back to a solid. So we start off with a solid, we heat it, it turns into a liquid, and then it turns back into a solid. So that is kind of the lab. We're going to go for about 3 more minutes after we get to that solid phase. So again, hopefully with that, that would give you the instructions of kind of how to do the lab. Maybe you need to rewind the video a little bit and write down a few instructions for yourself. Again, you need to write down enough so you understand what's going on. Some of the tips in your procedure. Always use 2 grams for each trial. That'll make life a lot easier for you. Never hit the Taro 0 button on the balances, or I shouldn't say, use that minimally, because when you go back to a balance, when you tiered it or zeroed it out, it will still not be zeroed out for you later on. So the best thing is to just record the numbers and do the math, subtraction to fill out your data table. You can heat the sample, it turns into a liquid and then back into a solid, and then you're going to go for 3 more minutes. And if you want to see a little bit of a demonstration of what's going on, I'll show this to you. What's going on here is they're actually taking some potassium chlorate. The oxygen is going to be driven off from it, and then they're going to add a fuel source to it, and that fuel source will start on fire. This is not what you're doing in the lab, to the most part. So right now, they're heating up the potassium chlorate. They're also turning a stick on fire. So it turned to a liquid, and then they're going to put that stick in there, which ignites the oxygen, and oxygen supports burning, so it's basically going to burn up that stick. So our lab's very similar, except for we're not actually going to be adding a fuel source to it. So that's just kind of, you can see the oxygen that was coming off of it. It's kind of a neat little experiment. You're going to do 3 trials in your procedure. While the first one's heating, the second one's going to be set up. And then as the second one's heating, the third one's going to be set up. That's how we would actually do the lab. If you make it here for the actual lab, you cannot mass out the evaporation basins until they are cool enough to touch with your own hands. That protects our balances. So some of this information is for students in class. This is the balanced equation that we took care of earlier. You need to figure out how to calculate the grams of oxygen in a 2-gram sample. This will be the theoretical grams of oxygen. Again, you've done this multiple times already. Nothing is new here. So what I'd like you to do is to pause the video, and I would like you to go from 2 grams of potassium chlorate to grams of oxygen using stoichiometry. I even gave you the mass potassium chlorate right there. So pause the video, use the balanced equation, this information, and solve this factor label problem. Well, hopefully you did, in fact, do the work. This is the work that you should have came up with the proper labels. This is going to be included in your report, so you can transfer this over to your report at some point in time when we kind of show you where it's supposed to go. Data table creation. How many masses are you actually going to need to collect for one trial? So kind of count through it. Okay, I need the mass of this, I need the mass of this, I need the mass of this, and see how many you can come up with. You should actually find that you should have about 5 different masses that you're going to need in this lab. One's going to be the mass of the evaporation basin, the mass of the evaporation basin with the potassium chlorate, the mass of the evaporation basin with the potassium chloride in the end, the mass of the oxygen that was given off. Those are all things that you would need for this lab. And if you were in class, you discuss this as a group. Data tables, there's information on your back cover. I believe it's tan in color. So if you find the back cover of your Unit 3 unit pack, it'll give you some data table information. You should definitely pause the video and go and find that if you need to do so. If you're reading that information, you'd find out that the leftmost column in a data table is called the independent variable. That variable really, what would be considered not a measurement? And then what goes in the second, third, fourth, and so on columns, those would be your actual measurements. Your title, this is all on your back cover. It says your title would be your dependent variable, possibly some units, versus your independent variable and possibly some units. So if you were in class, you would have 5 minutes to create a data table at this point in time for 3 trials. Again, what goes in that first column? What things would be there that would not actually be measurements? So the next lab, what would you have to have written up? You'd have to have your title. So you'd have the word title on a sheet of paper, and you would put the information that it talks about on the 75s. You'd have the word problem written out, and the problem's already written out for you on the 75s. You just transfer it over. You would write out a procedure, as much information as you would need to solve the lab. Again, you might want to rewind the video and go to the part where I was showing you how the lab was performed. You're going to have a data analysis section. In here, you're going to have a data table with title and column headings all set to go. So a title at the top and column headings for each column. And you're going to have one factor label problem where you go from 2 grams of potassium chlorate to your grams of oxygen. As you do math in the actual experiment, which will be part of the next video, that's where you're also going to have more math. I believe you're going to have 4 or 5 math problems here. Most of them is just going to be simple subtraction. Hello, folks. Today we are going to be doing a lab that's using potassium chlorate, and that's going to decompose into oxygen and potassium chloride. So I'm going to give you basically the lab and all the data that you need to make a data table from and to come up with the results from the lab. So what we're going to do is we're going to get the mass of a basin. So this right here is a basin, so we're going to get the mass of that right away. And we find out that the mass of that is 36.28 grams. That is the mass of the basin or the dish as we're going along. We're then going to add some potassium chlorate to that. So I'm going to add some potassium chlorate to that. and we're going to end up getting the mass of the basin plus the potassium chlorate, which is potassium chlorate, and that mass is 38.29. So that's the mass of all of this together. So what is the mass of just the potassium chlorate that you have to figure out? So then what we're going to do is we're going to take that potassium chlorate and we are going to put it on a ring stand, and we're going to put that above one of our Bunsen burners. So we're going to take that basin and put it above one of our burners. Show you what's going on with that. Hopefully I don't melt the camera. Not really seeing anything wonderful going on. Starting to see some melting at the edge of it. Some bubbles are forming. That's actually oxygen molecules coming out of the compound. Almost all of it has melted and turned to a liquid. Again, those are oxygen molecules that are coming out of the potassium chlorate. You can actually see a little bit of what looks like steam coming out. That's actually oxygen molecules that are coming out of this. Got some pretty intense boiling going on right now. Got some sound coming along with it. Oxygen's escaping. And when that oxygen has completely escaped, we have just turned it to potassium chloride inside of the basin. So we went from potassium chlorate and we turned it into potassium chloride, and oxygen has escaped. We'll continue. So 3 minutes has elapsed. I will take it off of here. I'll place it down. We'll let that cool for several minutes, and then we will get the mass of that. So we're coming back to everything over here. I'm getting the mass right now of the potassium chloride and the basin. And right now we are at 37.26 grams. And that is all the information that you need to do or need to have in order to do the rest of this lab. We are going to have you do several trials of this. So here you can see we're going to be using a larger basin. I've collected some data for you already. So 68.77, that is the grams of this basin. Then we would put the potassium chlorate in it. We added 2 grams of the potassium chlorate to it. So that gave us 70.77 grams, and that is the potassium chlorate plus the basin. Okay. And then when we were all done, the potassium chloride in the basin was 69.97 grams. Again, that's potassium chloride and the basin. Basin number 3, when we did that one, its basin, the mass of the basin was 37.26 grams. We added 2 grams of potassium chlorate to it. So the basin and the potassium chlorate had a mass of 39.26 grams. Again, the mass of the potassium chlorate was 2.00 grams. Over on trial 2, it was 2.00 grams as well. When the whole thing was heated up and we were left with just potassium chloride in the basin, the mass was 38.56 grams. So I'll kind of go through everything again. We originally started with a basin We added our 2 grams potassium chlorate to it, and that gave us a mass of 38.29. What's the mass of the potassium chlorate? Well, that would be 2.00 grams. Actually, 2.01 grams. We heated it up, and at the end, the total mass of the potassium chloride in the basin was 37.26. From that, you have to figure out how many grams of oxygen escaped from the basin. Trial 2, our basin was 68.77. We added 2 grams potassium chlorate to it. The total mass was 70.77 grams. That's the basin and the potassium chlorate. We put 2 grams of potassium chlorate in there. We heat it up. We're left with potassium chloride in the basin, and the end mass was 69.97 grams. So the difference from here, the 70.77 and the 69.97, that's how many grams of oxygen went into the air. Our trial 3, we started with a basin that was 37.26. We put 2 grams potassium chlorate in it. We ended up getting 39.26 grams total for that. You do the math on that. We put 2 grams potassium chlorate in it. We heat it up. We drive off all the oxygen. We're left with potassium chloride and the basin at the end, and its mass was 38.56 grams. So this is how much we started with total. This is what we have at the end. The difference in those two, that's how many grams of oxygen went into the air. That's where you're trying to figure out is the grams of oxygen that went into the air, and you're going to compare that to the mathematics when we do a factor label problem to find out the theoretical grams of oxygen that went into the air. There will be a video in this spot. So the experiment occurred, and now we're going to go through and look at your report. So do you have this correct balanced equation somewhere in your report? This should absolutely be in there. It talks about it on the 75s where it should be. This is what your data table should look like. So in the actual lab, as you were collecting data, if you're like, oh crap, I forgot to have a column for this, well, then you would just pop that in as you're going along. There's no need for averages at all. Trials are, in fact, your independent variable in this particular lab. Pause the video if you need to spend more time to look yours over. There's no averages that have to occur in this problem. Some of the errors that could have occurred in this lab. So in class, we would talk about this. So some of the potassium chlorate or potassium chloride bubbles over. It actually flies out of your dish or basin. We're expecting theoretically to get this many grams of oxygen out of our experiment. That's what our math tells us. That's how much we should expect to get out. This air right here, though, would make you think there was more grams of oxygen or less grams of oxygen. Think about that. Pause the video. Come up within your head. Would this air right here make you think that you have more than 0.783 grams or less than 0.783 grams of oxygen? This particular air right here, since this would be leaving the dish and oxygen is leaving the dish, anything that leaves the dish would make you think you would have more oxygen on your hands. So this particular air would actually make you think that you have more grams of oxygen than there actually should have been. So again, this air would make you think that there was more than 0.783 grams of oxygen lost in this experiment. All right, here's your next air. Potassium chlorate was not heated long enough or intensely enough with the flame that was there. Would this make you think that you have more grams of oxygen than 0.783 or less grams of oxygen than 0.783? Pause the video, write down your thoughts. This particular air, since it wasn't heated long enough, you actually did not get all of the O2 to leave, and therefore make the grams of oxygen less than you would expect. Here's your next air. Some of the potassium chlorate or potassium chloride flies out of some other dish and falls into your dish, and you did not notice it. Would that air make this 0.783 greater or less than you expected? Well, if something falls into your dish, that is adding mass to your dish. You're making your dish heavier. We calculated the oxygen by how much was missing out of the dish. So this chip that fell into your dish is going to make you think like you have less oxygen that came out of the dish. So this air would make you think that there was less oxygen lost than there should have been, because some oxygen did in fact bubble out, it did in fact leave, but something fell back in, which would make you think that there wasn't as much oxygen lost as there should have been. A chip falls off your dish or basin after the initial massing. So when we're heating these things, we're heating them up to about 1100 degrees. And that's a lot of stress on those dishes. So it does, in fact, have parts of the dish that come flying off, either the ceramic coating, the porcelain coating, or just parts of the dish as well. So we have a dish, a chunk falls off. We're going to think that that is oxygen that left. That's going to make you think that you have more oxygen that actually left the dish than you would have expected. And that is the lab. So most likely we'll have you take a picture of your lab and send it in. Just check It's Learning for more information or send us an email. Have a good day.